There are some other essential amino acids that can stimulate this master regulator of protein synthesis called mTOR in other tissues. But in muscle is very unique in that leucine serves as the primary trigger of mTOR activation in this tissue. And so making sure that we're hitting a so-called leucine threshold is very important in order to maximally turn on that mTOR complex and optimize muscle protein synthesis. And you may want to add in about Don's work in this because it's been so pivotal and important to the field.
Yeah. And basically, Dr. Donald Lehman, my longtime mentor, really helped perpetuate this understanding that there is a meal threshold. And what Dr. Alexis is talking about is this leucine threshold. And you guys are probably thinking, well, what is leucine? Where am I going to get leucine? I'll take a step back. The recommended, this really comes from high quality protein. Thank you to Element for sponsoring this episode of the show. Why should you be taking an electrolyte solution? Because many of us become dehydrated. We don't even know it. We are very active, and we might begin to feel things that relate to dehydration. For example, headaches, fatigue, even muscle cramps. Element is a science-backed electrolyte ratio solution, which, by the way, comes in a little cute powdered pack, 1,000 milligrams of sodium, 200 milligrams of potassium, 60 milligrams of magnesium. This stuff tastes amazing. And by the way, little hack, if you are on a weight loss plan where you are finding that you are hungry, throwing in a little pack of Element totally curbs your hunger. Well, at least it does for me and my patients. You've got to try this stuff. Get on the bandwagon. If you have not already, go to drinklmnt.com/Dr. Lyon. You will get 8 free single serving packs. It's a great way to share it. No risks. They will refund you if you don't like it, but you will. That's drinklmnt.com/Dr. Lyon. What is up, my friends? This is Dr. Gabrielle Lyon, and welcome to the Dr. Gabrielle Lyon Show. I am here with my lead scientific advisor, Dr. Alexis Cowan, who did her PhD at Princeton and is now doing her postdoc at Penn. One of my very dearest friends, and really a huge part of the course for muscle-centric medicine, which I'm going to tell you all about. In today's episode, we are going to discuss what muscle-centric medicine is, why muscle is important in the context of health and wellness, actions that you can take to improve your skeletal muscle health, and again, so much more. Dr. Alexis, how are you?
So happy to be here. It's been too long.
We joke and say it's been too long, but the truth is we probably talk every day, share studies, and look at new research frequently. It is a fact, totally. And before we dive into this, I want to clarify some things. What is muscle-centric medicine? Muscle-centric medicine is an approach to medicine that acknowledges the health of one's skeletal muscle tissue that has a significant impact on the health of other organ systems within the body. It is a perspective rooted in actionable behavioral recommendations capable of improving the physical health and sense of well-being of patients and people like yourself, as well as providers, health coaches, trainers, you name it, both acutely and in the long term. I do want to mention, we talk about a lot of different terms. Dr. Alexis and I are going to mention a lot of different terms. She's been on the podcast earlier, and we will also be starting a journal club, which will be kicking off in January. But to lay the foundation for you, what is muscle? Muscle, the skeletal muscle organ system, is the largest organ in the body, not skin. It comprises about 40% of body weight, which seems to be pretty consistent. Sister Alexis and I have looked into the literature because I've had some questions as, is it really 40%? Does that vary with weight? But 40% seems to be a consistent number. It is important for movement, posture, temperature, glucose regulation, also known as homeostasis, soft tissue support and metabolism. Skeletal muscle is a striated muscle tissue that is attached to bones via tendons. And unlike the other two muscle tissue types, which are smooth and cardiac, skeletal muscle is under voluntary control by the somatic nervous system, meaning you control its actions. Skeletal muscle is made up of a number of muscle fibers, muscle fiber bundles. This can vary in fiber type. Skeletal muscle fibers can be divided into roughly slow twitch type 1, fast twitch type 2 fibers based on certain metabolic characteristics and etc. Before we dive deep into this episode, I want to outline why muscle matters. And muscle matters for a number of reasons. Aside from aesthetics and sport performance, let's think about muscle as the public health key. So this is like the lever for public health. When I was looking at the CDC and the number of deaths for the leading causes of deaths, I'm going to read some of them to you. We have heart disease, cancer. There's unintentional injuries, stroke, so cerebral vascular disease, chronic lower respiratory disease, Alzheimer's, diabetes, chronic liver disease, nephritis, kidney disease, and there's more to that list. Notice that the majority of the causes of death that I have listed all have a unique metabolic component. And note that the skeletal muscle system, the organ of longevity, has an underpinning in nearly some capacity, in the capacity for nearly all of these diseases. Now, I just want to mention that skeletal muscle health is not on the list. Osteopenia, which is low muscle mass and strength and function, is not on this list. There is room for our improvement in the way that we think about things. The US, if we were to move to the quality of our health span, I want to lay out a few numbers for you. In the US obesity prevalence was 41% in 2017. From 2017 to March 2020, US obesity prevalence increased from 30.5. So this was from 1999 through March of 2020, from 30.5% to 41.9%. During that time, the prevalence of severe obesity increased from 4.7 to 9.2%. This is staggering, my friends. The obesity prevalence was 39.8% among adults aged 20 to 39, 44.3% among adults aged 40 to 59 years old, and 41% amongst adults aged 60 and older. This is a major problem. And I will mention that we talk about obesity as if it is something out there, but the risk factors for obesity begin very early on in life. And how we tie skeletal muscle into this, I would love to bridge the gap through speaking about insulin resistance. Skeletal muscle insulin resistance is a core factor. There are many issues with obesity and the diseases that ride alongside with obesity, but insulin resistance is a focal point. We hear that term thrown around a lot. What exactly does that mean? Insulin resistance, also called prediabetes, is characterized by elevated blood glucose levels, which, by the way, if you are tracking your metrics and looking at your blood work, insulin resistance can start when you begin to see your fasting blood glucose from 101 to 125 milligrams per deciliter. Again, I encourage you guys always to look at your blood work because you can begin to see things within your own body. There's also another way to test, insulin resistance. And I will mention, and Dr. Alexis and I have talked about this, euglycemic insulin clamp would be a number one way. That would be the gold standard that is not available to the public. HOMA IR, other things that perhaps are not routinely measured, but a way that you can begin to see how your body is doing is by looking at your fasting blood sugar. There's also an impaired glucose tolerance test, and that would be after a 75-gram oral glucose challenge. The number of that at 2 hours after that challenge, we see between 140 to 199 milligrams per deciliter. Again, the diagnosis of prediabetes is still somewhat controversial. One thing is for certain, a pre-diabetic individual has a 50% chance of developing type 2 diabetes within 5 years of diagnosis. This may be because by the time that they have looked at their blood work, it is somewhat advanced. And they are also at a higher risk for developing other metabolic disorders, such as those listed from the CDC, the causes of death. Really important to understand because we don't necessarily die immediately from things like cardiometabolic disease or cancer or diabetes. These are things that take time. Why skeletal muscle? Skeletal muscle is essential for glucose clearance and responsible for over 80% of glucose uptake from the food that you eat. So that would be called a oral glucose load, also known as a postprandial. That would be a postprandial glucose. Insulin resistance is caused. Now, there are many potentially different causes, and I'm sure, Dr. Alexis, you would agree, whether it is a receptor problem, etc. But overall, one could think of insulin resistance is caused by the desensitization of muscle to the insulin released by the pancreas to elicit glucose uptake, leading to, and again, this is quite oversimplified, but important to understand from a conceptual level, it leads to elevated blood glucose levels. Insulin resistance identified as an impaired biological response to insulin stimulation of target tissues, which primarily involves liver, which there's not much you can do about liver, muscle, and adipose tissue. Now, I'm going to be wrapping this up shortly, but I do want to lay at your feet some of these concepts because as I listen to my own podcast and listen to other lectures, there is a way in which we take for granted that we're all defining things the same. And that's why by taking a step back, we can really move forward because now we are all talking about the same thing in the same way. In the presence of excess calorie consumption, more insulin is typically required to traffic glucose into these cells. The resultant hyperinsulinemia further contributes to insulin resistance. The more insulin you make, the more excess calories you consume over time. There is a cycle that continues until pancreatic beta cell activity can no longer adequately meet the need of the insulin demand. So the pancreas is where you make and release insulin. Insulin is a peptide hormone. Its primary responsibility, although it does have more, is to address glucose from the bloodstream, out of the bloodstream into cells. I will mention that weight gain can occur alongside with hyperinsulinemia, and the anabolic effect of insulin decreases as tissues become more insulin resistant, and weight gain, I believe, eventually will slow down. Oftentimes people will plateau with weight gain. Some people may agree, some people may disagree with me, but one thing that we do know is that the metabolic consequences of insulin resistance can result in things that you care about, like hyperglycemia, hypertension, dyslipidemia, high levels of uric acid, elevated inflammatory markers like HSCRP, endothelial dysfunction, and somewhat of a prothrombotic, tongue twisters, a prothrombotic state. Insulin resistance. I'm going to drop a bomb on you guys. Insulin resistance is thought to precede the development of type 2 diabetes by 10 to 15 years. Skeletal muscle insulin resistance can appear decades before the onset of beta cell failure and symptomatic type 2 diabetes. Now, big point here is that you do not need to be obese to have insulin resistance. There's a few more things that I'm going to mention. I'm going to mention that insulin resistance negatively impacts glucose regulation, but it does not seem to be equally impactful for most other hormonal actions of insulin. So it's impacted differently, including the promotion of protein synthesis. While insulin becomes ineffective in certain ways within glucose regulation, insulin has multiple roles in the body. For example, the promotion of protein synthesis, de novo lipogenesis, and cell proliferation. De novo lipogenesis is the generation of fat. And there are other factors and other defense mechanisms that insulin influences. There is no general insulin resistance, but selective impairment of insulin signaling. Would you say that that's true, Dr. Alexis? Thank you to Paleo Valley for sponsoring this episode of the show. You guys have heard me talk about this product. If you have not tried it, you absolutely should. They have a whole host of different meat sticks, beef sticks, turkey sticks. They have a cranberry orange turkey, you name it. You can rotate through it, even teriyaki. They're absolutely delicious. Dare I say, I even crave them. Easy to travel with. They're fermented. These sticks taste different than any beef or meat stick I have ever had. And it, by the way, when you ferment it, it creates this natural occurring probiotic. Everyone is talking about gut health. It's the next big thing. And I am absolutely convinced that this product supports good health overall. Go to paleovalley.com/Dr. Lyon and you will get 15% off. Go to paleovalley.com/Dr. Lyon or use the code Dr. Lyon for 15% off.
Yeah, I mean, I think there's different ways that people define insulin resistance. And a lot of time, I think it's conflated with glucose intolerance, which I'm not sure is actually a fair assumption to make. Just by looking at glucose dynamics alone, you can't actually tell if the defect is in insulin signaling. So in order to, effectively identify insulin resistance in the system, you really have to look at insulin levels in response to a carbohydrate load. So in response to glucose in the diet, or whether that's also in like an oral glucose tolerance test. Looking at glucose dynamics and insulin dynamics in response to that load, that will tell you something about whether or not the muscle is insulin resistant. But looking at glucose levels alone, which is often done, I think is an incomplete way of actually determining what's going on, because in some cases, an individual might have impaired insulin secretion, which is actually what's impairing the ability to clear that glucose. And instead of, on the flip side, having an insulin resistant muscle that requires more insulin to get that glucose into the muscle. So it's an important distinction to make that's often overlooked.
Dr. Alexis, you're bringing up a really good point, and let's delve a little bit deeper. So we're going to go one layer deeper. Inherently, most people do not have a defect or issue with their pancreas. But over time, there are certain dietary practices that are believed to impact the release and the health of the pancreas over time. And I believe that that's kind of what you're getting at. Why don't you highlight that?
Yeah, sure. I'd love to. So I think the advent of very low carbohydrate diets, which would include carnivore diet and ketogenic diet, have really kind of exploded over the past decade. And prior to that, ketogenic diets were being used selectively in some patient populations, including in epilepsy, with quite a bit of success. But now that this diet, as well as the carnivore diet, have kind of entered the mainstream, and touted to have so many benefits, which they may in the short to medium term, but we don't really have long-term data to suggest whether or not there could be harms as a result of not eating carbohydrates for extended periods of time. And one of the clinical observations that seems to be creeping up in literature and in clinical observation is that the pancreatic beta cells may have an issue adequately producing insulin after very long periods of carbohydrate restriction. And so when I was mentioning before, only looking at glucose dynamics kind of being incomplete, I think this is especially the case for any individuals who may have had very long-term low carbohydrate diets, to just ensure that the defect is actually with getting glucose into muscle via insulin signaling and not insulin production itself.
And to and just to highlight a little bit about what she said, there is a place for low carbohydrate diet. I absolutely believe that. We talk about that in my book, Forever Strong, that if you are metabolically healthy, then typically, and you are training and you are exercising, which we're going to talk about exercise, then you are utilizing your carbohydrates. With the statistics that I gave you at the beginning of this episode, where 40+% of individuals are suffering from obesity and potentially insulin resistance beginning before we are even seeing outward signs of obesity and the issues that ride alongside that, there may be a role for carbohydrate restriction. The goal, though, is to actually get people to be, number one, insulin sensitive, and number two, to have an appropriate body fat percentage and an appropriate healthy skeletal muscle mass percentage. When you are starting out on a nutrition plan, my recommendation, and I could easily say our recommendation, is we typically don't recommend going below 100 grams of carbohydrates a day. Again, this is a variation depending on the person. Exactly for that reason, you can get certain benefits. And by the way, I say this cautiously because I know there are a lot of providers listening. There are many providers that are in the low carb community. And again, we do believe that there is a place for a low carbohydrate diet. It is also important to think about things in context over time. And when we think about things in context over time, on one end, we see what the average American carbohydrate intake is 300 grams a day. We have seen the implications of that over time. We have increased levels of obesity, hypertension, high triglycerides, cardiovascular disease, impaired insulin. We know what happens over time. On the same hand, a long-term carbohydrate restricted diet, what happens when eventually somebody goes back to add in carbohydrates? If you don't use it, you lose it. That is not to say we are recommending high levels of carbohydrates over time. I think that can be damaging. In fact, that's the definition of diabetes. It's not that the carbohydrates are causing that, but it is elevated levels of blood glucose over a specific time period. The other aspect to that is humans are extremely flexible, nutritionally flexible. We want to make sure that you're able to get in a wide variety of fruits and vegetables. When you restrict carbohydrates too low, I'll ask you this, Alexis, when you restrict carbohydrates too low and you begin to add them in, things like fruits and vegetables, even though we consider them healthy, have you seen somewhat of an exaggerated response?
Yeah, absolutely. And I think it really trends with, it can vary a lot by the person, but it really can trend with how long somebody has been restricting these foods. We really need to have a better understanding and also monitoring of people once they're coming off of these diets. And it's actually really nice that the technology is kind of catching up with this, because continuous glucose monitoring has become more popular, and now people can kind of take that get those insights in their own hands to understand how their body is responding, and how that's making them actually feel. So, for example, if somebody's getting a big blood sugar spike, they may notice that induces quite a bit of brain fog for them. So, like, even if you don't have this CGM on, you may be able to identify feelings in your body that are telling you, like, I'm getting a blood sugar spike right now. I need to go for a walk, or I need to do some air squats, something like this, to clear this excess sugar. And then moreover, I need to figure out why these spikes are happening. what have I eaten, and like what have been my dietary patterns that could have contributed to this, or my movement patterns, things like this. I think it's super important to consider the long-term effects, like you mentioned before, because for a lot of things, there can be diminishing returns over time. And what started out as a great intervention that provided a lot of health benefits could ultimately end up causing harm if we're not really honest with ourselves about how we're doing on that diet. And I think with a lot of the lack of religion that's in our society now, people often turn to dogmas in other areas, including diet, to kind of fill that hole that's really kind of wired into the human psyche that really likes to grab onto something to believe in. And sadly, I think diet's not the place to do that, because we have to give ourselves the flexibility to be changing our nutritional habits with the changing demands on our lives and our goals. And I think we really need to maintain flexibility in that area to optimize health.
That is so beautifully said. And we're going to cover that topic in a different podcast because it's it's so important. Basically, what you are saying is that rather than there being solely empirical data and solely an empirical conversation about what the influence is of these, not just macronutrients, but the way in which they play out in our daily life, how we're eating, how we're training, that the conversations that we have now are, whether it's political or emotional or agenda driven, it is not purely empirical. And that is, quite frankly, a very important conversation to have. So stay tuned for that, you guys. It's important to understand where certain narratives are born, how long they've been going on. A lot of the information and the divergence of nutrition camps is not actually a new thing. It is decades, if not centuries old. And this is just another iteration of an old story. Moving on to if an individual, so basically to tie this up into a bow, how do you know if you are insulin resistant? Again, this is one of the things that we cover when we teach muscle-centric medicine, but markers that you would look for are a culmination of markers. You would look at fasting insulin levels. You would also look at fasting blood glucose levels. You would also look at potentially triglycerides and other markers in addition to you could potentially look at uric acid levels, also blood pressure. Did I miss anything on our list?
Just one thing maybe that could be added is like an oral glucose tolerance test, especially if we suspect that insulin resistance might be kind of early in its development. A lot of times, fasting glucose levels will be normal. Like you mentioned before, it can take up to 10 years to actually get like type 2 diabetes or even prediabetes. So we want to make sure that, looking at fasting insulin can be an early marker, but also looking at the dynamics of glucose in the bloodstream will really tell you how effectively that glucose is getting into the muscle. So the oral glucose tolerance test is something that I would add. And people can kind of also achieve that somewhat using a CGM, just to kind of look at the dynamics of what's going on if they don't have access to like a lab that can do that for them.
Yeah, that's a great idea. Basically, you'd be monitoring your blood sugar after a 75-gram load over 2 hours. And it's not fun, tastes gross. And I'm not saying that you do this, but this is definitely one thing that an individual can do. Now there is something else. I don't know if I mentioned this, but in addition, lean, non-diabetic, normal glycemic, regular normal blood sugar, individuals with a high risk of developing type 2 diabetes, such as if your parents, a parent or both parents are diabetic, have been reported to show moderate skeletal muscle insulin resistance very early. So there's a supporting role for insulin resistance as an early stepping stone to the development of type 2 diabetes. Another place that I see insulin resistance in individuals that have not been insulin resistant before, which is then going to move us to muscle health and the types of skeletal muscle we're going to move right into that category, is that women going through menopause. One of the things that we see over and over and over again in the clinic and patients that Dr. Alexis and I work on together is we will see elevated levels of fasting blood sugar and fasting insulin creeping up, but maybe within the quote technical norm. And one of the reasons that we believe this is happening, aside from any kind of hormonal changes, is the loss of muscle mass and the change in this tissue, specifically around menopause, which leads us to, I almost feel like what I think that we'll do is you'll kick it off. We'll talk about the two broad classes of muscle, and then we'll talk about training for each of those particular, we say fiber types. It's not really like that, but it's important to recognize that skeletal muscle, it is a complex organ system. There's a lot of things that go into it, whether it's mitochondria, whether it's slow twitch fibers, fast twitch fibers, the metabolic capacity of each, the myokines. Skeletal muscle is amazing, but there are very specific things that you can do, and you can get an impact quite swiftly. Again, impacts meaning from exercise may happen nearly immediately. So Dr. Alexis had just mentioned, if you have a large meal and you see your blood sugar rise, what is something that you could do immediately? We recommend that someone go for a 10-minute walk after every meal. Just do it. And it could be squats, it could be push-ups, you name it. If you're at my house, you could do some pull-ups. If you're at Alexis's house, you might do kettlebell swings. We have been known to, in between reviewing research, just bust out a few kettlebell swings and carries. But talk us through the two broad classes of muscle fibers, fiber types, and why they're important. And then I think it would be really cool to just touch on, which I'll mention after you do that, some supplementation that may support both.
Great. Sounds good. So you mentioned earlier, and now we're going to dive into the specifics of each, but there's two broad classes of muscle fiber types. These are the slow twitch type 1 fibers and the fast twitch type 2 fibers. So with regards to the type 1 fibers, these are considered as red muscle. So they're often called red muscle because they actually look red to the naked eye, and that's due to actually their mitochondrial density. So these muscle fiber types are very enriched in mitochondria, and they're highly metabolically active. So because of their mitochondrial density, they're able to very effectively burn both carbohydrates and fatty acids and ketones, if there's ketones around as well. And often these substrates can be burned even at rest. So among the red type 1 muscles are included the postural muscles. So these would be the muscles that are active just, if you're seated, especially if your back is unsupported, or if you're standing still. There's a lot of muscles that are involved in just keeping your body erect, and keeping, your structures in the proper alignment. So that's why these muscles are very important even at rest, and they're contributing quite a bit to the resting metabolic rate for that reason, because they're metabolically active. Even if you're not actively contracting them, they're kind of running in the background to support you. They're also enriched in myoglobin, which is an oxygen-binding protein that essentially allows there to be a bountiful amount of oxygen present in the muscle to support that mitochondrial function. They're also relatively low storers of glycogen. So glycogen is a polymer of glucose. Glycogen is stored post-meal. Insulin actually stimulates glycogen formation, but primarily in the type 2 fibers, which we'll get to. So the type 1 fibers can store small amounts of glycogen, but not a whole lot. And so for that reason, they actually have a smaller cross-sectional area. If you were to look at them under a microscope, they're kind of thinner fibers that have this mitochondrial density, but they aren't swollen with the water and the glycogen that comes along with that water. So then with regards to the type 2 muscles,
I want to add something there. I want to add
please.
something. When you think about aging, typically this is you imagine a person who is aging and you see that potentially they've gone from bigger muscles to thinner muscles, and they've gotten kind of scrawny and tinier. There is a change in fiber type. It will go from type 2 to type 1. And these are not the big, bulky fibers that we typically think about when we think about an exerciser. They, again, do not store a ton of glycogen. And Dr. Alexis and I both feel that there is huge importance in not just being strong, but also having mass. And eventually, if you are a provider, we will talk to you about the way in which they are identifying skeletal muscle. But both muscle mass for glycogen disposal or glycogen storage, glucose disposal matters, as well as strength. And type 1 fibers matter a lot, in my opinion, for mitochondrial capacity. You're thinking about volume and cardiovascular activity. And this will highlight ways in which you would train specifically for that.
Yep, absolutely. And I think maybe one distinction that might be important to make is that I'm not entirely sure, but I'm fairly certain from the research that the fiber types less so shift during aging, but instead are actually lost. So it's like the type 1 fibers are maintained better in the aging process, and the type 2 fibers are the ones that are atrophying and kind of being lost. I'm not entirely sure, and we should look into it, but whether or not those are happening by shifting the type 2 fibers to type 1, or it's just loss of total fiber number, and like fiber number is decreasing. But at any rate, the muscles are shrinking, the cross-sectional area is going down due to the loss of the type 2 fibers, and you're left with weaker muscles because the type 2 fibers, like we'll mention, have more force production capabilities relative to the type 1, so you're losing strength and function alongside with total muscle fiber type number.
And the good news is you can do something about both of these.
Yes, absolutely. These fates aren't inevitable, although I would say the tone in the medical literature is often quite bleak, but that's only because they're reporting on, the average individual.
Which, by the way, you guys listening to this, nothing about you is average. And the whole idea of this community is to be forever strong. And that is why we are working to educate you, providers, health coaches, trainers, to really rethink the role of skeletal muscle, which, by the way, you all know it's incredibly important. And then bring the science behind it, and not just science, but also the art of practice. Moving us into the fast twitch type 2X fibers. There's type, yes. So why don't you hit us with that?
Yeah, so I wasn't going to get into the nuance of the different types of type 2 fibers.
I didn't even mean to say that, but Stefan,
it's okay.
leave it in. Type 2 fibers. We'll just talk about type 2 fibers.
Okay, great. Yeah, so in contrast to the type 1 fibers, the type 2 fibers are fast twitch fibers, and that means that they're recruited in response to high intensity contraction and movement. So if you're, lifting a heavy weight rather quickly, you're engaging lots of these fibers. If you're doing sprints, you're also engaging these fibers. So these fibers have a lower mitochondrial density relative to type 1. They also have a lower metabolic activity at rest. They aren't primarily being engaged whatsoever. If you're just, chilling, standing still, etc. That's really the domain of the type 1 fibers. The type 2 fibers are really going to be recruited specifically when you're engaging them. These fibers have high levels of glycogen, which is that storage form of glucose that's important to support energy metabolism in the muscle. And because they have high levels of glycogen happens to like to associate with water molecules. And so glycogen and water result in this swelling effect of the muscle fibers. And so the type 2 fibers have a higher cross-sectional area, making them larger. And they're able to more effectively engage in high intensity, very quick contractions. And so the fast twitch muscles, in contrast to this type 1 muscle fibers, the type 2 fast twitch muscles have very low endurance. So the type 1 muscles are really made to be able to go low and slow. They're able to sustain contraction for long periods of time, but force production is low, whereas the type 2 muscle fibers have the ability to generate an immense amount of force, but only for a short period of time. And so they're really fast, but finite.
Yes. Let's give examples of when you would be working each system. And again, we're saying this as if the fiber types are separate, which they're kind of all bundled together. And we are also speaking about it in a way where we're working these systems separately. It doesn't exactly work like that. The human body is an incredibly dynamic process. And I think as humans, we like to put things into frameworks for thinking about it. And that's very valuable, because if we can prioritize certain frameworks, then we can think about it in a way that it makes sense. So again, please understand that we are aware of the complexities of these systems and processes, but to be able to break it down so that everybody is on the same page is probably even more important than all the complexities. Both fiber types, and I don't even want to say fiber types, but both modalities of, we'll just say fiber types. Both fiber types are important for different reasons. I don't know a different way to say that. It is important to train for both type 1, and that would be, what kind of training would that be? That would
That would
be
be your endurance training. Oh, sorry.
endurance,
Yes.
something I will never be doing. But Shane and some of the other people that we know like to run marathons. Those would be a individual who is primarily a type 1 fiber type individual versus, and that would be zone 2 training. Would you agree with that? That would be somewhat zone 2 training.
Yeah, zone 2 would be like the epitome of the type of training you would do to optimize the type 1 fibers, but even lower intensities than that, like low intensity steady state exercise, like going for a walk. This would also be an activity that would preferentially engage the type 1 fibers.
And we talked about insulin resistance, and we're focusing on this episode really about some of these core fundamentals of muscle-centric medicine. We go into great detail, but again, this is just one concept of a much broader picture. Picking insulin resistance as a root perspective, how do you avoid it? You get out there and you move, and it doesn't have to be complicated. It just has to be done. And that's really important to understand. You can improve insulin sensitivity. One of the other things that we didn't mention is that muscle at rest requires insulin for the movement of glucose out of the bloodstream into muscle cells. Exercising skeletal muscle does not. Not only does exercising skeletal muscle not require insulin, but a bout of exercise, you will see improvement in insulin sensitivity. 24, I think even, well, we'd have to pull up some of the data, but possibly even 48 hours later. We also see changes in HDL, LDL over time. Again, you may see an influence immediately. It still takes time for it to be withstanding. Moving us to, and we should mention something else. Talking about type 1 fibers, talking about training mitochondria, let's pick 2 supplements. I'm going to highlight 2 supplements, one that I know you love, when you are thinking about maintaining the health of this tissue. This is a primary mitochondrial tissue. Again, it's other things, satellite cells, etc. A ketone ester. And I would say my second choice would be, or my first choice in no particular order, would be urolithin A for mitochondrial function. We're not going to go into huge detail about that, but urolithin A is a postbiotic that is really highlighting the gut-muscle axis. How we would dose it, we use MitoPure, and I dose it at 500 milligrams twice a day. For a ketone ester, Alexis, is there one that you love, or is there a dosing strategy that you use in particular?
Yeah, so I love the cognitive switch from Juvenescence. I think they've done such an incredible job on that product, and they used to taste absolutely horrific. And
It's amazing, actually.
it's come such a long way. It literally is flavorless now. You can add it to basically anything, and you won't even notice that it's there. I'm spacing on the dosing per scoop, but I typically will use 1 scoop before doing a zone 2 workout, in addition to using the urolithin A. I also like to use some carnitine, which we
Ooh,
didn't talk about, but I think it can be a good support also for fatty acid oxidation, and that tends to work incredibly well for really getting you sweating, getting your mitochondria engaged, and just really optimizing for your type 1 fibers health.
I love it. I love it. Okay, fast twitch type 2 fibers talked about low mitochondrial density, low metabolic activity. And by the way, skeletal muscle, we talk about it in generalizations. The reason that we are highlighting muscle fiber types is because there's a change with aging. There's different levers that you can pull. And again, why not take it a layer deeper? Skeletal muscle at rest typically uses fatty acids, so fatty acid oxidation. And then we think about glucose and glycogen disposal in skeletal muscle. We don't necessarily think about fiber types when we talk about it in this overarching theme. Type 2 fibers have low metabolic activity, high levels of glycogen, a larger cross-sectional area. Think about those as your biceps or your quads. How are you going to do squats and do resistance training to get more jacked? So typically higher load, really hypertrophy training and strength training. I think that that's a great way to support, typically type 2 fibers, but when you think about that, you do think about hypertrophy. I don't know if there's anything else that you would want to add there. I do have one supplement aside from protein that I would add, but is there anything else about a type 2 fiber that you would recommend, and maybe other additional exercises for that?
Yeah, so sprints would also be included within this realm of type 2 fiber engagement. Basically, anything that's an explosive movement that's happening over a short period of time. And something that I should mention, in addition to glycogen being a major fuel source for those explosive movements, creatine and creatine phosphate are also very important part of the energy production system in these muscle fiber types. And so I'm not sure if creatine was the supplement you were going to mention, but it would be
It
one.
is.
Yes,
It is. It
surprise.
is on my list. It is on my list to kind of tie this all together for everybody.
Great. Yeah. Yeah. So creatine is a really important energy source for very quick bouts of explosive movement, but
Would you
this
say
system
10
will,
seconds or less? 10 seconds or
yep,
less?
10 seconds or less of energy, like all out sprint or very, very heavy lift to failure. It would be something like this, that system's going to be engaged alongside of glycolysis, which is burning glucose to quickly produce energy, but it's also not sustainable unless those glucose carbons are ending up into the mitochondria. But that can't happen in these very intense workouts because the muscle doesn't have enough time to make ATP that way. It needs to make it as rapidly as possible. And that's where the creatine and the glycolysis really come into play to support energy production.
I love that. And my recommendation would be between 3 and 5 grams of dietary creatine. Again, I'm trying to limit the amount of recommendations. There's also some evidence, some great evidence for fish oil and skeletal muscle. But again, we're going to limit this to just bite-sized pieces for you guys. Let's talk about a baseline exercise recommendation that would be reasonable for the beginner. Thank you to Inside Tracker for sponsoring this episode of the show. First and foremost, guys, I'm a physician, and I'm a physician that cares about you. And the sponsors for the show are all sponsors that I have picked and use their services or their products. Inside Tracker is an amazing, amazing tool for you guys to know what is going on within your body. You have to take control of your own health and wellness. You cannot put it off. You need to know what your blood counts look like. You need to know what your iron status looks like. You need to know why you're feeling great or why you're not feeling great. Inside Tracker makes blood testing easy. Go to insidetracker.com/Dr. Lyon. That's insidetracker.com/Dr. Lyon, and you will get 20% off the entire Inside Tracker store.
Yeah, absolutely. So the American Heart Association would recommend 150 minutes of cardiovascular training per week, and that would be like vigorous training. Something that you can have some options with is considering doing something like 120 minutes of vigorous cardiovascular training, and that could look something like a zone 2 training. Zone 2 is really maximizing your mitochondria's function and mitochondrial fat oxidation, and that's why it's often used to optimize for mitochondrial health and the mitochondrial health of muscle specifically. Zone 2 training, it's going to vary somewhat based on your age, but it's essentially a heart rate range that's sustainable over a long period of time. And so typically a zone 2 training session could be anywhere from 40 minutes to an hour, but you could consider either doing 150 minutes of zone 2 training per week. Or if you want to change it up and also get a lot of the same benefits, you could do 120 minutes of zone 2 training weekly, and then also add in 30 minutes of HIIT training, high intensity interval training, and that could be split into 3 10-minute sessions or 2 15-minute sessions. HIIT training has been shown to actually confer quite a bit of benefit in a shorter period of time. So for people who have time crunch, they have busy schedules, HIIT training can be a good way to get a lot of the cardiovascular and muscular benefits of training without having to sink, a full hour into your training session. So it can be a nice option.
And let's just differentiate high intensity interval training from sprint interval training. Sprint interval training, as we're talking about it, we would define it as 90% or higher VO2 max. Would that be a fair agreed upon number? And then 80% or so for high intensity interval training. There's a lot of different ways to do high intensity interval training. You could do it with weights. You could do it with air squats to push-ups to an Airdyne bike or an assault bike. There are many different modalities as to how to do that. We have programs which we outline that. It doesn't have to be complicated. It just has to be effective. The other aspect that there was just a phenomenal paper. Let's see if I can pull that up. Well, it's here somewhere. There was a phenomenal paper that looked at the loading recommendations for muscle strength, hypertrophy, and local endurance. And it was the title of the paper is a loading recommendation for muscle strength, hypertrophy, and local endurance, a re-examination of the repetition continuum. You guys can check that out. It is an open access paper. And what it highlights is that it's more fluid than we think. It's not that it's 3 to 5 for strength and 8 to 15 for hypertrophy, et cetera, and then a certain amount for endurance, that there are other things that come into play. And again, what we are looking for is an adaptation. The adaptation that we are looking for in muscle-centric medicine is, number one, we do want to see improvements in body composition. We do want to see improvements in muscle hypertrophy, muscle strength, and endurance. These are all metrics that you physically can measure and track. How fast do you do a 1-mile run? How many push-ups can you do? How many squats can you do for time? How much can you deadlift, or et cetera? There's all different ways, but having a metric that you can track is really important. The other thing that we are looking for in muscle-centric medicine is your blood levels. You have to know, what is your fasting insulin? What are your triglycerides? What is your ApoB, which is a risk factor for cardiovascular disease? What is your fasting blood sugar? What is your blood pressure? There are multiple things that we must take into consideration. Now, I am just going to mention this. There are medications that can have a negative impact on skeletal muscle health. These include statins, typically fat-soluble statins. There are over 40 million individuals on statins. This affects it affects skeletal muscle health. It can affect coenzyme or CoQ10 status. It can affect muscle pain, muscle weakness. We won't go into detail about it, but we will at a later episode. NSAIDs, which are super common. This could be, again, ibuprofen. These things affect muscle health. Also antibiotics, fluoroquinolones, Cipro, they can cause rupture. Another medication that can impact metabolism would be a beta blocker. Beta blockers can have a negative impact on metabolism, many different things. And on the flip side of that, if you have low thyroid hormone can affect glucose transporters. It can affect metabolism. If you have low levels of testosterone, this can affect the anabolic capacity of skeletal muscle. Exercise may not directly increase testosterone, but it does affect skeletal muscle. There are receptors that can translocate to the cell surface, et cetera. So there are things that really help with muscle health. As it relates to, we could mention again, muscle protein turnover. Why? What do we think about when we think about muscle health? We really measure muscle health on the things that we mentioned. In the literature, you are going to see a biomarker of muscle health, and that is muscle protein synthesis. It is not directly related to mass. It is what is used to measure that skeletal muscle is incorporating amino acids. It is getting a robust response of what it is that we are asking of the tissue. Dr. Alexis, you can add to that. Thank you to First Form for sponsoring this episode of the show. I would love to share with you their creatine. They have a micronized creatine monohydrate. Creatine has been in the game for easily 60 years. And by the way, one of the things that they always talk about with creatine is its effect on muscle health and performance, allowing your body to generate more ATP. And by the way, there's more and more research coming out that creatine is wonderful for brain function, especially if you are older. Again, it is amazing, it is safe, and there are other benefits to creatine than just muscle health. So if you are thinking about your longevity and your brain function, I encourage you to try creatine. You can get some amazing creatine at firstform.com/Dr. Lyon. That's firstform.com/Dr. Lyon, and grab your very easy to mix creatine monohydrate.
Yeah, sure. So muscle protein synthesis is kind of one side of the coin. The other side of the protein turnover coin would be muscle protein breakdown or muscle protein degradation. Both these terms mean the same thing. One pathway, MPS, the muscle protein synthesis, is making new protein with amino acids that are input into the system, which would include both non-essential and essential amino acids. So the non-essential amino acids are the ones that our body can produce itself, versus the essential amino acids are required to be consumed through the diet in order to support this muscle protein synthesis process. And then on the flip side, the muscle protein degradation or breakdown is the action of the muscle to break down its protein. And actually, both sides are very important. So if we're trying to gain high quality muscle tissue that has good function and also nice size, depending on what your goals are, both sides of that coin are important, because as it turns out, if muscle protein breakdown or degradation is impaired to too much of an extent, that can actually harm or negatively affect the quality and the function of the muscle. So it's important to, we don't want to just inhibit all muscle protein breakdown because we want to maximize muscle protein accretion or like the growth of our muscles. We need a proper balance of the two pathways. And so for muscle protein synthesis, what we're really thinking about for optimizing this pathway is making sure that we're getting all of our essential amino acids in the right timing and in the right dosing. And specifically, there's one amino acid called leucine, which is one of the 3 branch chain amino acids that's super important for optimizing this process in muscle specifically. So there are some other essential amino acids that can stimulate this master regulator of protein synthesis called mTOR in other tissues. But in muscle is very unique in that leucine serves as the primary trigger of mTOR activation in this tissue. And so making sure that we're hitting a so-called leucine threshold is very important in order to maximally turn on that mTOR complex and optimize muscle protein synthesis. And you may want to add in about Don's work in this because it's been so pivotal and important to the field.
Yeah. And basically, Dr. Donald Lehman, my longtime mentor, really helped perpetuate this understanding that there is a meal threshold. And what Dr. Alexis is talking about is this leucine threshold. And you guys are probably thinking, well, what is leucine? Where am I going to get leucine? Leucine, I'll take a step back. The recommended, this really comes from high quality proteins. When you care about muscle health, you must care about creating a nutrition plan that supports muscle health. And one way to do that is to make sure that you are getting, obviously, your dietary protein. Number one, this hierarchy, the total amount of protein. There is also, so we recommend 0.7 to 1 gram per pound ideal body weight. The frequent question is, how do I know what my ideal body weight? My answer is, when was the last time you felt amazing? Make this your ideal body weight. You don't have to be perfect to make progress. Again, it doesn't have to be perfect to make progress. Understanding that 0.7 to 1 gram per pound ideal body weight, understanding how much protein you need, and then dosing it appropriately to stimulate MPS. And we use MPS as a marker, biomarker for, and I caution the listener, I'm not trying to overstate this physiological response of muscle protein synthesis, but we do know that when you are not stimulating tissue and it is below this threshold of muscle protein synthesis, individuals are at more risk for losing not just skeletal muscle mass, but lean tissue in general. And that is this 24-hour protein synthetic rate. Your organs are always turning over. The body turns over around 250 plus grams of protein a day. You're not going to be eating that. It is very important that you support skeletal muscle health. When you eat for skeletal muscle health, you typically hit enough for the health of nearly everything else. And again, I don't mean to overstate that, but it's important to understand. And when I think about what the recommendation is, the current recommendation, the RDA, is 2 to 3 grams of leucine a day. That is the equivalent of around 30 grams of protein, which it doesn't actually work because, for example, if you listen to the RDA, if you're 115 pounds and the RDA is 0.37 grams of protein per pound, that would equal 45 grams of protein. So there is some discourse in and variability in these various recommendations, which is why we're trying to clarify it for you. The RDA is the minimum to prevent deficiencies. The minimum to prevent deficiencies might be around 45 grams of protein a day. None of you want to prevent deficiencies. Not only that, we talked about insulin resistance. We don't have time to talk about aging on this podcast, but we will do another episode for aging, and you must be able to keep up with protein turnover. The RDA is not sufficient for aging. It is also not sufficient for metabolic health and body composition goals. We recommend 2 to 3 grams per meal, which looks like 30 to 50 grams of high quality protein. I have a free protein guide on my website. You guys can check that out. I have it in my book, Forever Strong, which is right here behind me, which should be out by the time this podcast comes out. Overall, I'm just going to wrap this up. I know it's been about an hour, a little over an hour for you guys, and I really appreciate you sticking with it. We talked about muscle health. We talked about muscle health in the context of obesity, in the context of insulin resistance, and that it plays a role in the top handful of causes of death in the US. And we also talked about the exponential rise in obesity. We're talking about obesity, but we're also talking about the rise of unhealthy skeletal muscle. And that's really what is important. Talked about skeletal muscle tissue, what you need to do for it. Again, this is a very broad general overview, the marker in which we look at for skeletal muscle health, and then a strategy for easy way to get protein. If you are a provider and you are interested in learning more, please join us in our providers. We have the Institute for Muscle-Centric Medicine, in which Dr. Alexis Cowan is the lead scientific advisor. We will be offering this to healthcare providers. We also offer this to health coaches, trainers, and individuals who are interfacing with clients. So if you guys are interested, you can go to the website, you can sign up, and or shoot us an email if you have any questions. With that being said, We love you. We're so happy that you joined us. If you like this episode, please rate, review, shoot us over messages. You can find Dr. Alexis Cowan on our website as well as on her own Instagram. What's your Instagram handle?
It's at Dr. Alexis Jasmine, and it's Jasmine with a Z, so it's Jazmyn. And you can find me there. I'm posting all the time, nutrition stuff, exercise,
Dogs.
lots of things. Dogs,
Like
cats,
dogs.
big animal person. So if you like that kind of content, come on over.
Yes, she has tons of content, and we will also be doing a journal club monthly. If you're interested in that, you can email info@drgabriellelyon.com. That's info@drgabriellelyon.com. You guys have to understand, we move the needle together. We don't do this alone. We need you. We have to share the message. And in order to share the message, we have to get people trained up in these core concepts. Again, I'm Dr. Gabrielle Lyon, and till next time.